Hi guys, happy Monday. So welcome to the first video that I'm doing so far for pre-calculus, talking about circles and parabolas for week 3. So as you go through the course, you'll notice that the top bar you have pages 1 through 9, but this week isn't going to be not all 9 pages. I think it just goes through page up to page 4. The rest of it is going to be for week 3. So we have a little bit of an introduction in the beginning about the different types of conic sections, we call it, so kind of slices when you're talking about cones. So as you can see here in the picture, we have two cones, just one on top of the other. The first one being a parabola, which we should pretty much be pretty familiar with being x squared, typically as we think about it as x squared. We have a circle, we have an ellipse, which is kind of more on a tilt, and then we have a hyperbola, which actually goes through both cones, if you will. It slices through both of the cones. So it says, as you continue your study of pre-calculus, we will begin our exploration of conic sections. You've probably studied parabolas before, but ellipses and hyperbolas will be new. A conic section is formed by the intersection of a plane and a cone as shown in the image. So again, like I was saying, if you take a knife and you kind of slice it, it's going to give you these different shapes. We have a couple essential questions and then what to expect. There's a lot more in here than what's actually graded. You don't obviously have to absolutely do everything that's not graded, but I suggest that you do to give you more of a feel for it, since it is on you to make sure that you learn this. I'm going to try to do as much as I can, the best that I can with these videos, but again, it will be up to you, and let me know as we work through this if you need any help. Alright, so on page 2 it goes through a couple of important key terms for this whole entire lesson, pages 1 through 9, or all the way through page 9. The first thing we talk about is a cone, which you're probably pretty familiar with, a three-dimensional figure with a circular or elliptical base and one vertex, kind of like a party hat. Coplanar, set of points, lines, rays, line segments, etc. that lie on the same plane. So with coplanar, it's a way of describing these things. So let's say you have 2 points that are on the same plane, they would be coplanar points. So you want to make sure you actually say what is coplanar after the word coplanar. Then we have an ellipse, which is a curved line forming a closed loop where the sum of the distances of 2 points, which we call foci, to every point on the line is constant. So an ellipse is kind of like where you have your circle kind of drawn out. Typically we think of those as an oval, and that's going to be more in next week. A focus is one of the fixed points from which the distances to any point of a given curve are equal. I think that should say, as I talk about kind of later when we talk about parabolas, we have a hyperbola, and if I read that to you right now, it's just not going to make a ton of sense, so I'm going to make sure I definitely go through the definition again when I do this next week for week 4, because again, we're not doing hyperbolas today, just the circles and parabolas. Alright, so next up, beginning our conic section is talking about circles. So a circle is a conic section formed by the intersection of a right circular cone and a plane. Now, as we know, circle is going to be the second from the left. That's going to be where all of our points in the circle are equidistant from the center, and we have a couple of key points here. So we have the equation of a circle, x minus h squared plus y minus k squared equals r squared. H comma k is the center, and r is going to be the radius. Now the other two formulas that are really important for the circles part is going to be x1 plus x2 divided by 2, comma, adding the y's together, so y1 plus y2 divided by 2. That is our midpoint formula, so finding the middle between 2 points, the midpoint. And then our second formula is actually going to be the distance formula. We've worked on this a lot as well in pre-calc as well. So x2 minus x1 squared plus y2 minus y1 squared. It doesn't matter whether you do the y's first or the x's first. You're squaring it and adding it together anyway. As long as you have them from 2 to 1 in the right order, you will be good to go when you're finding the distance. Alright, so the lesson actually has some pretty good videos for you guys to go through when they're going through the examples. The lady who does them actually does a pretty good job, kind of like what I'm doing here, but what I wanted to go through with you guys mainly was those questions at the bottom of the page where you have to try them on your own. So I wanted to make sure I worked those out so you guys could see if you're getting them right. I know they give you the solution, they give you the answer, but I wanted to show the work for you as well since the examples are already done for you. I didn't want to waste your time doing that, but I wanted to make sure I did these for you. So what I'm going to do is I'm going to start with number 1. So for question number 1, and for all these questions, they want us to write an equation of the circle in standard form. So what's going to happen here is I need to find two things. I need to find my h comma k, which is my center, and my r, which is my radius to finalize the equation. What I always suggest that you guys do is to go ahead and draw a circle and draw out what they actually give you so that you can make sure you have everything that you need to write the equation, so 11, 8, and 1, 2. And what I'm going to do first is find our center. So between the two endpoints of the diameter right in the middle is going to be my center. So that's why we review the midpoint formula so that we can find the middle between these 2 points. So I'm going to take my formula, add my x's together, divide by 2, comma, add my y's together, divide by 2. 11 plus 1 is 12, divide by 2 should give me 6, and then 8 plus 2 is 10, divide by 2 should give me 5. So the center of the circle should be at the point 6, 5. Now the next thing I'm going to do, the final thing, is to find the radius. Now if you recall, the radius is half the diameter. So I don't necessarily want the distance from the two endpoints, so endpoint to endpoint, but what I do want is the distance from the center, the middle, to at least one of the other endpoints. So I'm going to pick 6, 5 as my center, and then I'm actually also going to use 1, 2. So I'm going to subtract my x's, so 6 minus 1 squared, plus the difference of my y's, so 5 minus 2 squared, which should give me 5 squared. 6 minus 1 is 5, and then 3 squared, and that should get me the square root of 25 plus 9 after I solve that, 25 plus 9 getting me 34. So my radius is the square root of 34. Now I'm going to take what I found, which is going to be the center of my circle, and my radius, and I'm going to plug them into the equation of a circle. So remember, h and k is going to be the 6 and the 5, so I get x minus 6 squared plus y minus 5 squared, that should definitely be a 5, that's my mistake, equals my radius, which is square root 34 squared. Square root 34 squared is just 34. Alright, so now that we got the first one out of the way, the next one should be a lot quicker in terms of actually working them out and solving them. So I'm going to start with finding the midpoint, since I have endpoints of a diameter just like I did last time. So I'm going to add the x's together, divide by 2, and then add the y's together, divide by 2. Negative 10 plus 14 is 4, divided by 2 should get me just 2. And then 13 plus negative 3 is 10, divided by 2 should get me just 5. So the center of my circle is going to be 2, 5. And then I'm going to go ahead and use the distance formula from the center to at least one of my points. It doesn't matter what direction you're going, to one point, one endpoint or the other, as long as you use the center and then one of the endpoints. So I'm going to go ahead and use the first one, which is negative 10, 13. So I just rewrote 2, 5 up at the top. I'm going to take negative 10 minus 2 squared plus 13 minus 5 squared. Negative 10 minus 2 is negative 12 squared plus 13 minus 5, which is 8 squared. And then as I square those, I get 144 plus 64, which I should get square root of 208 for my radius. Now when I take those and I plug them into the equation, I know h is 2 and k is 5, so I'm going to take x minus 2 squared plus y minus 5 squared, and then I want the radius squared at the end, so that's going to take off the square root, which is just going to be 208. Alright, so from those examples, that's all that I did, because it would be a super long video if I did all of them. Let me know if you need help with any of the other ones 3 through 6, but I just moved on to the next part, which is given the equation in circle and general form, convert to standard form. So the first thing you see me doing here is grouping all the x's together and all the y's together, and we're going to do the process known as completing the square. So you'll see that I took x squared plus 30x plus blank. You always want to make sure you leave a blank there. That's going to be the new c part of our quadratic. And then y squared minus 18 squared plus blank equals the negative 290 on the other side. So then to the left-hand side here, I'm taking my b term, the b which is a 30 because it's ax squared plus bx plus c, and I do a little formula where I take half of b and then square it. So b divided by 2 squared is 15 squared, which is 225, which is what I went ahead and filled in the blank there next to the 30x. And then I'm going to do the same thing for the y one. So I'm going to take negative 18 divided by 2 squared, and that gets me 81. So I'm going to put that in the blank spot next to the negative 18y. So then also whatever your new c's are, so 225 and 81, you have to make sure you add that. If you're doing it on the left-hand side, you have to do it to the right-hand side as well. Now to factor something like x squared plus 30x plus 225, I do a quick little shortcut where x squared is x times x, so I write that in green. 225 is 15 times 15, so I write 15, and then that first sign, the plus sign, is going to determine what goes in between them, so x plus 15 squared, and then I do the same thing with y and then 9, but it's going to be minus because of that sign, so y minus 9 squared. And then I take negative 290 plus 225 plus 81, and I get 16 for the radius squared. And this is actually going to be my final answer. Now for the next question, I'm going to go ahead and take x squared plus 30x, because I'm going to group the x's together, plus blank. But I know that 30 divided by 2 squared is going to be 225 from the last problem. And then I'm going to take the y squared, but plus 30y, because I have to take the negative 30y and add it to the other side. And then I know that's going to be 225 as well, and set that equal to negative 449. So the right side of your equal sign is always going to be a regular number. Now, since we did all the work on the last screen, I know that that's going to factor down to x plus 15 squared plus y plus 15 squared equals the negative 449, but don't forget to add your 225 and another 225, so I went ahead and combined those and I made it 450, because that's 225 plus 225. And so for my final answer, I get x plus 15 squared plus y plus 15 squared equals just 1. All right, so number 3, again, keep in mind I want everything with a variable to the left-hand side and my numbers to the right-hand side. So I'm going to take x squared plus 28x plus a blank, group those together, plus y squared plus 18y plus blank, group those, and then equals negative 255 because I have to subtract it over to the right-hand side. I'm going to take my little formula b divided by 2 squared for my first grouping, so 28 divided by 2 squared gets me 196. And also don't forget to add that to the right-hand side to your negative 255. I'm going to do the same thing for 18, but from the last two problems ago, we know that it's going to be 81 because 9 squared is 81. And then again, don't forget to add that to the right-hand side. Now, I know that x squared is x times x. That's how I break that down. 196 is 14 times 14. The first sign is a plus, so it's going to be plus x plus 14 squared is what it factors down into. And then my next group is going to be y plus 9 squared. And then equals negative 55 plus 196 plus 81, which gets me a grand total of just 22. And that's all I need to do. And last but not least, number 4. So again, all the x's, I want to group those together. So x squared minus 24x, because we had to subtract it to get it to the left-hand side, plus y squared plus 26y, because that was a minus on the right-hand side, we have to add it to get to the left-hand side, equals negative 312, because we do have to subtract it to get it to the right-hand side. Over here in green, I'm just doing the little b divided by 2 squared to figure out what I'm going to get. Negative 24 divided by 2 squared is going to get me a positive 144 in that first blank spot, and then don't forget to go ahead and add it to negative 312 as well. And then I'm going to do the same thing for the 26. So 26 divided by 2 squared should get me 13 squared, which is 169. And then I'm going to go ahead and put that into the blank space in my second grouping, and then also adding it to my negative 312 and my plus 144. Now I'm going to factor this down. Hopefully you're catching up or catching on to what I'm doing. So x, it's a minus sign, and then 12 times 12 is 144, so x minus 12 squared, and then y plus 13 squared. You probably learned this a different way in Algebra 1, but this is just a strategy that I use, so it's up to you how you want to factor it. Hopefully this helps. If not, just keep using the method that you've been using and you'll be fine. So now I'm just calculating negative 312 plus 144 plus 169, and we end up with just 1. Alright, so moving on from circles into parabolas, it says, in previous courses you defined a parabola as a quadratic function in terms of x. We said that earlier on the very first page where it's typically x squared or ax squared plus bx plus c. Those parabolas were concave up or concave down, so either pointing up or pointing down. In this course we will see parabolas that open up, down, left, right. The left-right part will probably be new to you, but we'll get through it anyway. A parabola is the set of all points in a plane that are equidistant from a given point called a focus and a given line called the directrix. So my parabola, any point on my parabola, which you'll see here kind of labeled as P1, Any point along this parabola is always going to be equidistant to two different points, the focus and the directrix. Well, the directrix is a line, but any point on the directrix, I guess you could say. So the blue lines that I just drew, those will always be equidistant from each other. There's a couple of different forms for a parabola depending on whether it's facing up, down, or left, right. So what you'll see here is that we have our parabolas on the left, which are either pointing up or pointing down, as you can see. We use the formula above, which is where we take x minus h squared first, and then 4 times p times y minus k, and I'll explain what p is in just a moment. Then in the graphs on the right, we have the formula for those, which is flipped. So now we have y minus k being squared equals 4 times p times the x minus h. So depending on the direction of your parabola and where it's pointing, so for example, this one's pointing to the right and then pointing to the left, it is going to change the equation that you use for your particular parabola. So now in these practice problems, and again, the lesson goes through pretty well with the videos, those examples, so I just wanted to go through these problems here. We want to write an equation for the parabola given this information. So for number one, we have a focus at -6, 2, and then a vertex at -6, -1. Like always, I do suggest for you guys to draw this out, so I went ahead and drew out my little coordinate plane very loosely. I have 6, 2 and 6, -1. Something that I definitely want to point out to you guys that you have to know is that your parabola will always be pointing towards your focus. In other words, your focus will always be inside of your parabola like I drew here. Now, since my parabola is pointing up, and I know that because it's facing or it's going towards my focus, I know I'm going to use the formula that says x minus h squared equals 4p times y minus k, and that's just based on the last page that we talked about. So you have to know what your parabola looks like in order to pick the equation to use. Now, another thing to make sure we know is that from the focus, which is on the inside of my parabola, to the vertex, that distance is the same distance as my vertex to my directrix. So if you go back and kind of look at that picture from the first couple of slides, you'll see it looks something like this, obviously loosely drawn. The distance is the same on both sides of the vertex to the focus and to the directrix. So from the focus to the vertex, it was a distance of 3 because I'm going from 2 to -1, which I underlined. So that means I'm going 3 more down to get to my directrix. Well, from the vertex -1, that y value, down 3 is going to be down to -4. So my vertex I know is -6, -1. So that's going to be my h and my k. So h is -6, k is going to be -1. I also need to know what my p-value is. Now the p-value is the distance from the vertex to the focus. I have already figured out that the distance from the vertex to the focus is going to be 3. That's the only other piece of information that I need. Now what I'm going to go ahead and do is plug in all these numbers. So I have to take x minus h, so x minus -6, and then minus -6 is going to turn into +6. And then I have 4 times p, which is 4 times 3, and then y minus -1, which is y plus 1. So x plus 6 squared stays that way, I don't do anything there. 4 times 3 is 12, and then y plus 1 will stay. And this is going to be my final answer for question number 1. Alright, so for question number 2, I'm going to draw this out like I did before. I'm going to make my x-axis a little bit longer to encompass the focus, which is at 5, -2 that I just drew, approximately, and then 9, -2. Remember, your focus is always inside your parabola, so I know this is going to be pointing to the left. Now, what I also know is that they're on the same horizontal plane, but my focus goes from 5 to the vertex, which is 9. The distance from 5 to 9 is just a distance of 4. To the directrix is going to be another 4, because remember these are going to be symmetrical here, or at least the distance. So I know that it's going to be at x equals 13 for the directrix if we need to know, but all I really care about here is making sure I have the equation correct. So since I know this is pointing to the left, I'm going to have y minus k squared equals 4 times p times x minus h. Now the p-value again is the distance from the focus to the vertex, and something that I didn't mention before is that if your graphs are pointing either to the left or down, you want to make sure that your p-value is in fact the negative number. If it's up or to the right, it'll be positive. If it's left or down, it will be negative. So I'm going to go ahead and plug these numbers in. So I have y minus k, which is negative 2, so plus 2, and then 4 times negative 4 times x minus 9. So I get y plus 2 squared equals negative 16 when I multiply, times x minus 9. And that should be it. That's my final answer. Alright, so for number 3, I'm going to draw that out again. So I have my focus at 3, 2 approximately, and my directrix, which is at y equals 6. So you want to be careful about how you draw this. It's not at x equals 6, but it's going to be at y equals 6 up top. Now, based on some of our characteristics, I do know that the vertex is immediately in between the focus and the directrix. So the distance from the focus to the directrix is 4 because you're going from 3 to 6, so that's going to be a distance of 4. So cut that in half, and you're going to have a distance of 2 going from the directrix to the vertex, and then another 2 going from the vertex to the focus. And that's important because my p-value is going to be reflecting that 2, that distance. So I know my vertex is going to be, well, let's see, if it's 2 above 3, 2, well, that's going to be at 3, 4. And I want to use the equation x minus h squared because we're going up or down equals 4p times y minus k. And my vertex, like I said, is going to be 3, 4, and the p-value, the distance is 2, but since it's pointing down, I want to make sure that I make that into a negative 2 to reflect that my graph is pointing down. So as I go ahead and plug in those numbers, I get x minus 3 squared equals 4 times negative 2 times y minus 4. The x minus 3 squared, I'm not going to do anything there, I'm just going to leave it like that, and then 4 times negative 2 is negative 8 times y minus 4, and that is going to be my final answer. Alright, and last but not least, number 4. So again, make sure you draw this out. I have my vertex at 0, 4, so it's actually going to be on the y-axis, and my directrix is at x equals negative 1, so that's going to be a vertical line. So what the problem doesn't tell me is where the focus is, but since I know where the directrix is, I know that this parabola is going to be starting at the vertex and pointing to the right, because they have to be opposite each other. Now, from the directrix to the vertex, it's a little distance of 1 from negative 1 to 0, so I know it's going to be the same to the focus on the other side, which means that my p is a positive 1 value because we're also pointing to the right, and I know my vertex is 0, 4. So since we're pointing to the right, for my equation, I want to use the one that says y minus k squared equals 4 times p times x minus h. So as I go ahead and plug in those numbers, I get y minus 4 squared equals 4 times 1 times x minus 0. And the y minus 4 squared is just going to stay. X minus 0 is just x, so 4 times 1 times x is 4x, and that's my final answer. So I'm going to use a very similar strategy here for these problems than what we did for the circles, and the first example is already done for you in the problem, so I'm going to move on to number 2. I'm going to group all the x's and the y's to one side, and the x value or the y value that's squared, I don't want the number with that. I want the number on the other side, so I'm going to put the plus 1 on the other side. I'm going to go through the completing the square process with b divided by 2 squared, which is going to be 4. I want to make sure I add that to the other side as well. This turns into x plus 2 squared when I factor it equals negative y plus 5. And I want to make sure I try to have just a positive y, so I'm going to factor out that negative sign and change it into negative and then times y minus 5. Alright, so for number 3, I'm going to go ahead and group again. So I'm going to do my 2x minus 9 on one side, and I'm actually going to add the negative y squared to the right-hand side so it turns positive. It's going to make my life easier. But then I also want to make sure that I subtract 2y to the left-hand side, which I did make a little mistake here. So then when I go through completing the square, that's going to get me a 1. It should be y squared minus 2y plus 1, but it's all okay. We make mistakes. So that's going to be 2x minus 9 equals y plus 1 squared, even though it should be y minus 1. Don't forget to add that 1 to the other side as well, so we get 2x minus 8. After I factor that out, I'm going to get 2 times x minus 4 equals y, which should be minus 1 squared. And last but not least, the last problem. Again, I'm going to try to make all the x's and y's positive, so I'm going to keep the y minus 39 on this side, but I'm going to go ahead and add x squared to the other side, so I get a positive x squared minus 12x, so I'm not going to make the same mistake this time. and then I'm going to go ahead and take the x squared minus 12x and complete the square on that side. So to complete the square, we take b divided by 2 squared, so negative 12 divided by 2 squared should give me 36. Don't forget to add it to the left-hand side as well. So I get y minus 3, not equals 3, I'm going to fix that in a second. I get y minus 3 equals, and then after I go through the factoring process, that should take us to x minus 6 squared. From here, there's nothing really that I need to do, so this is my final answer. And as a final thought for everything this week, you can head back into my learning and you can see everything that's due. Next week, I will be covering hyperbolas and ellipses, so keep an eye out for that. I hope this helps. If you have any more questions, please just let me know, and I'll be more than happy to help you guys out, and good luck for this week.